Welcome to Study Loop.
This is the solution for problem 68 from chapter 17. So here we're asked to calculate the pH at 5 different points on a titration curve for the titration between barium hydroxide at 0.1 molar with 0.125 molar HCl. So we'll calculate the 5 points, indicate the volume of equivalence point, and we will sketch the graph. So first, let's calculate the moles of barium hydroxide that we're beginning with. So we have 0.1 molar barium hydroxide, and that's times 0.015 liters, or 15 milliliters, and then we get the moles as being equal to 0.0015 moles. But it's important to remember that this is moles of barium hydroxide. So we have 2 hydroxides. So if we need the moles of OH, we need to multiply by 2 and get 0.03 moles. This will be important for the rest of the problem. So now we can calculate the first point when 0 acid has been added. So we have the moles of OH, which is 0.003, divided by 0.015, which is our volume, and we get 0.2 molar. And if we take the POH, so the negative logs, POH is equal to 0.7, and then pH will be equal to 13.3. So we'll skip part 2, and then we'll do part 3. So I want to do the equivalence point first, or second, before I do any other points, so I can strategically pick the other points that I want to work with. So at equivalence, we've shown that we have 0.003 moles. So at equivalence point, we'll have 0.003 moles of acid added. Now to calculate that volume, it's going to be 0.003 moles divided by 0.125 molar, which is the concentration of the acid, and we get 0.024 liters. So this is 24 milliliters is our added acid, and our pH, since it's a strong base and acid, is equal to 7. So now let's go back and look at the second point that we want to do. And we can go ahead and just take half of the equivalence point. So we'll look at 12 milliliters of acid. So here, to get the moles that we've added, we're going to divide concentration. Sorry, we're going to multiply concentration by volume times 0.012 liters, and that gives us 0.0015 moles. Now, if we subtract this from our initial moles of base, because the reaction will be complete, we get 0.0015 moles of base. Since we already calculated the equivalence and we know that this is half of the equivalence, we could have just looked at this value here and divided by 2 and gotten the same result. So that's the moles of base. Now we just need to know the final volume. So since we've added 12 milliliters and we began with 15 milliliters, we can say our final volume is 27 milliliters, or 0.027. So we divide by that to get concentration of hydroxide, which is 0.056. And then we can get POH is equal to 1.26 by taking the negative log. And from there, we can subtract from 14 to get pH is equal to 12.7. So for the first 3 points, we have our 3 pH values here. Now let's open a new page here and let's work on the 4th point. So we did 1224, so now we can do 36 milliliters of acid to keep things simple. In these problems here where you can pick the parameters, then you can choose whatever you want, or any points should do. So since when we add 12 milliliters of acid, we get 0.0015 moles. And since this is 12 milliliters beyond the equivalence point, we know that this is all excess. And so if we divide by the total volume, which would be 36 plus 15, we get a value of 0.029 molar acid. And then if we take the negative log, we get pH is equal to 1.53. And we can quickly do our same process for 0.5, 48 milliliters. We now have twice the previous excess. We calculate concentration by using this volume plus 15, so 63 milliliters. We get 0.048 molar, or we could have done 2 times this. And then from there, we can calculate the pH by taking the negative log as being 1.32. So now we can go ahead and draw our curve. So let me open a new page, try to draw this as nicely as possible. So we have 0, let's go with 25 and 50. This is volume of acid. Up here we have pH, so 0, about 7, about 14. So since we're drawing by hand, it's obviously not going to be perfect. We just need to make sure that we're paying attention to where our points should lie. So our points here will be in red. Our first point was at 0 milliliters of of acid, and a pH of 13.3. So it's going to be up here somewhere, close to 14 on 0 base. Then we can add our second point at 12 milliliters, about halfway to 25 as 12.7, so just slightly lower, about halfway. Our third is pH 7 and 24. Our fourth is 1.53 at a volume of 36. And then our fourth is 1.32 at a volume of 48, so about there. So then we can sketch here. We're still doing a strong base and a strong acid, so our curve should reflect that by going straight and then sharply diving and then leveling off quickly. So that should be a rough sketch of what your plot should look like.